Assalamualaikum. So we will present about our case study math. Before we start, my name is FAIZA IASHA binti Osman. My matrix number is 10DDT 20F1077.
Yes, so my name is Huwaini Husna binti HASNAN. My matrix number is 01DT20F1071.
My name is SALAAMAH binti ABDUL RAHIM. My matrix number is 01DDT20F0.
My name is IZZATI binti SOFIAN. My matric number is 01DDT20F1082.
Okay. First things, we have to know about the definition spanning tree. So, spanning tree of a graph is a collection of connected edges that include every vertex in the graph, but that do not form a cycle. Many such spanning trees may exist for a graph. The minimum spanning tree is the one whose cumulative age weight have the smallest value. However, think of it as the least cost path that goes through the entire graph and touch every vertex.
So before we proceed to our maps, I want to explain about map we choose and algorithm. Map we choose is Bangkok and we choose a Prim's algorithm. Prim's, also known as Jarnick's algorithm, is a greedy algorithm that finds a minimum spanning tree for a weak indirect graph. This means it finds a subset of the edges that forms a tree that includes every vertex, where the total weight of all the edges in the tree is minimized.
Okay, so next, for method, observe all the edges and their weight. Observe already connected edges. Observe those edges who are not connected. Assign a key value to each knot depending upon the order of the knot. Now select the knot that is not connected. Turn it as root knot R and has minimum weight and include it in connected edges or in minimal spanning tree. Okay, so now select the next nearest knot with minimum weight and include that knot in the minimum spanning tree. Repeat the same procedure until all the knots are not connected.
This is the map of the Bangkok that we choose. So this is the location of the city, which is acts as the vertex, and the length of the road. The route is the act as the edges of the between the vertex. So according to Prim's, and the reason why we choose the Prim's algorithm, the Prim's algorithms, when we choose, firstly we need to choose the shortest route available, and then after that, to choose another vertex or another edges, we need to choose the vertex, the edges that is incidence to the vertex that we already chosen before. So, for example, first one, if we choose the Siam square, we start the our map on Siam square. The first vertex is Siam square. The only route we can go next is only Payatai or Lumpini Park. But because we are using Prim's algorithm, we have to choose the shortest between the two. Therefore, we choose Payatai because the length between the two vertex, the two city, is 0.5. The edges that is incident to Payatai is are edges that connected to Victory Monument, which is that has 1.0 kilometer. Another one is the Lada Palace that has 1.2 kilometer as the length between the two city, and the other one, Democracy Monument, that has 2.5 kilometer, and Chinatown that has 2.2 kilometer. The length between the two city. So we need to choose the the least amount between the four available route. Here, the shortest route is between Payatai to Victory Monument, which is 1.0 kilometer. Therefore, the next vertex that we choose after Payatai is Victory Monument. Then, after that, the edges or the route that available is to Chilada Palace and to Lumpini Park. But between these two, to Chilada Palace is 2.0 kilometer, where the Lumpini Park is 3.2 kilometer. So the chosen one will be the Chilada Palace, which is 2.0 kilometer. Then, after we have chosen the Chilada Palace, the available route, the available edges is to Payatai, to Democracy Monument, and National Assembly Hall. But we cannot choose the Payatai vertex or city because we already chosen it before when we connect it from Siam Square to Payatai. Therefore, that edges is cannot be chosen again because it will create a cycle. Therefore, cannot make or make uh, cannot make a spanning tree. So the available or the route left is to National Assembly Hall and Democracy Monument. So here, choose the Democracy Monument because it is more shorter than the National Assembly Hall. Then when we arrive to Democracy Monument, we have another another few routes that we can take, but we cannot take the Payatai and the Chilada Palace because we already chosen that city before. And also we cannot choose the National Assembly Park because we are already chosen that before too. So the only left vertex or city that we can choose after that is National Monument and Chinatown. And when we compare these two, the route to Chinatown is much more shorter than the route to National Museum. Therefore, we choose Chinatown after that. After we choose Chinatown, we have four other routes, but we have two routes that we cannot choose anymore because we are already chosen that city before. Therefore, we cannot go back. And you know, this is a trip. You don't want to go back to your previous location. So we are left with the route to National Museum and Memorial Bridge. Okay, so we came from National Museum to the Chinatown. So when we arrived to Chinatown, we have four other routes that we can choose, but we can choose the route to National Museum or to Democracy Monument or even to Payatai because we already chosen that vertex before, that city before. And because this is a trip and also this is a BRIM algorithm, we cannot choose the city that we already have chosen, vertex that we already have chosen. And because this is a trip, you don't want to go to your previous city. That's it. So we are left with the route to Memorial Bridge. So we choose the route to Memorial Bridge, which is 1.9 kilometer. And then from Memorial Bridge, we'll go to the last vertex or city that available, which is Lumpini Park. That is 3.2 kilometer. So we will now go to the calculation. So this is the calculation or the solution from the for the total minimum weighted for the map. So like I said, we have started at Siam Square because Siam Square has the shortest wages, the shortest edges available, which is 0.5 from Siam Square to Payatai. So we start from there, and the length is 0.5. Then from Payatai, we go to Victory Monument that has 1.0 kilometer length, and then from Victory Monument to Tiada Palace is 2.0 kilometer. From Tiada Palace to Democracy Monument is 0.9. Democracy Monument to National Assembly Hall is 1.0. From National Assembly Hall to National Museum is 3.0. From National to Chinatown is 1.3. Chinatown to Memorial Bridge is 1.9. And lastly, Memorial Bridge to Lumpini Park is 3.2. Then when we calculate the sum for all of these routes, it will result with a total minimum weighted of 14.8 kilometers. Then we will take a look at the resulting map. This is the resulting map of the minimum spanning tree of using Prim's algorithm that we get. This is the minimum spanning tree that we get from Prim's algorithm. That we already implemented that. So firstly we start at Siam Square, and then we go to Payatai, which is the length is 0.5, and then Payatai to Victory Monument, which is 0.1. Victory Monument to Tiada Palace is 2.0. Tiada Place to Democracy Monument, and so on. So this is a more clear view of the resulting minimum spanning tree that we get from the map using Prim's algorithm.
So the importance of the Prim's algorithm is very simple and easy to implement. It helps to simplify the graph in easy way. It is simple and straightforward and easy to work on it. That's all. Thanks.
Thank you.